please do so. It tells you a wee bit of the background to it, what we're looking to do in proof by contrapositive. So moving right on to the example here, it says prove that if n cubed is not even, then n is not even. We've got our first statement here, P, implying our joint statement here, Q. So what we're looking to do to make a contrapositive statement or conjecture is we are wanting to make the implication that not Q implies not P. So we're flipping P and Q around, and we are going to create that contrapositive conjecture and try and prove that to be true. So what is not Q? Well, Q says that n is not even, and if n is not even, there isn't much of although sometimes we say in a negation statement that there isn't a black and white. In some cases there is. So if we're told that n is not even, then the negation of that is that n is even, or n is not odd. So we're saying here that if n is even, it implies that her second statement here, n cubed is not even. The negation is n cubed is not odd, or n cubed is even. Okay, so now we have a conjecture which is the contrapositive. We've got not Q implies not P. We want to see if we can demonstrate that to be true. So if n is even, then we're going to define, we'll say let n equals 2k for some integer k. This is z by now. So if n is 2k, then n cubed is going to be 2k cubed, which can be written as 8k cubed. And we're trying to determine whether it is even or odd, and so we can write 8k cubed as with a common factor of 2, which is good enough for us to imply that then that's an even number. Okay? Because it's a multiple of 2. So, if n cubed is an even number, given that n is even, we have proven our contrapositive to be true. I.e., if n is even, it implies that n cubed is even. We've shown that to be true. As the contrapositive is true, then by logic the original conjecture is also true. We don't need to do any more than that, and ideally you're confident in your own mind that if the contrapositive is true, then the original conjecture is also true, and that's the way logic works. Okay, so that's the idea of proof by contrapositive. We have to create this contrapositive statement, not Q implies not P. We then prove that to be true, and then we can state with great satisfaction and 100% conviction that the contrapositive is true, then the original conjecture is also true. Okay? That's proof by contrapositive.